may be seated.
The state of Missouri versus Governor Brantley. Marc.
Are all parties present?
Yes, Your Honor. Kelsey Sewanee for the prosecution of Brantley Marc, acting in favor of the state.
Your Honor, Jasmine Bell and Aaliyah Johnson defending Governor Brantley Marc.
Thank you. Governor Brantley, please rise to hear the charge. You are charged with assault and murder of Ellie Victoria on the 7th day of July, 2014. How does the defendant plead?
Not guilty, Your Honor.
Thank you, Governor Marc. Good afternoon, ladies and gentlemen of the jury. I begin with some general comments on our roles in this trial. Throughout these proceedings, you will be judges of the facts. However, when I tell you what the law is, it is my view the law that must prevail. There is one basic principle that are fundamental to your role as jurors. It is the requirement for proof beyond reasonable doubt that the presumption of innocence. Governor Brantley has no obligation to prove that he is not guilty or to explain the evidence offered by the prosecutor. The law presumes he is innocent until proven guilty. The state has charged Governor Marc with first-degree murder. I now welcome the prosecutor to the stand.
Your Honor, I intend to convict Governor Brantley not only with a solid motive, but with blood and skin cell samples found at the scene of the crime, in addition to his known presence at the time of death. The motive is this: Brantley Marc, runner-up in the recent Missouri senatorial race, lost not only that, but also his campaign manager, the victim, Senator Otto Marc. Analysts found blood and skin samples at the crime scene on both the victim and the glass through which he made his escape. According to a phone call made by Senator Marc, Governor Marc was indeed present at the time of death. Governor Marc has not given any comment as to why he was there at the time of death, so there is no alibi as to why he did not commit this crime.
Thank you. The defense counsel has been statement.
Good morning, ladies and gentlemen of the jury. My name is Jasmine Bell, and it is my privilege to represent Governor Brantley Marc in this case before you today. You have heard the prosecutor explain what she hopes to be proven, but I assure you she is not giving you all the facts.
The prosecutor has said Governor Marc was present at the estimated time of death. But what if Otto Marc and the victim's wife were about at this time? Police reports filed on the night of the incident describe strange bruises and lacerations on Senator Marc's chest and neck. Senator Martin dismissed them as minor gardening accidents. But I do believe there is much more to the story than the blood on the broken window, and I intend to prove my client's innocence in this tragedy.
Thank you. The prosecuting counsel may now call the first witness.
I wish to call my first witness, Officer non-conforming.
Please place your right hand on this random piece of paper. Do you solemnly swear to tell the truth, the whole truth, and nothing but the truth, so help you God?
I do.
Sheriff, please tell the court what happened in the morning of July 7, 2014.
According to our initial investigation at the crime scene and later analysis of the evidence, we suspect that the victim was murdered at 10:32 p.m. by strangulation. We received a call to our emergency services hotline from the victim's wife several minutes after the suspected time of death, claiming that she found her husband dead after returning from her home and seeing the assailant jump out of the window just moments after she entered.
What did you find when you entered the home of the victim?
Upon my arrival, I came across shattered glass with traces of blood, a snow globe broken and bloody, the dead victim's body on the bed, and Senator Martin at the scene of the crime.
And how does Senator Martin appear?
She appeared distraught and catatonic. She had deep scratches on her arms and a large bruise on her chest.
Thank you, Sheriff Martin. Further questions?
Does the defense wish to cross-examine?
Yes, sir.
Sheriff Norby, did you happen to ask Senator Martin about the deep scratches on her arm and the wound on her chest?
Yes, she appeared to be in a gardening accident earlier that day.
But the wounds appeared fresh.
Yes, however, we couldn't prove anything that we didn't see ourselves, and there were no other witnesses.
Could you describe the state of the room as you saw it?
Oddly enough, Little was disturbed. The most we found out of place was the broken window, a knocked over nightstand, and a snow globe broken on the floor beside the bed.
Were there any obvious points of entry? Was there any physical evidence of someone breaking into the house?
No.
So, even if Governor Marc had killed the victim, he would have been let in the house by the victim himself, and with nothing disturbed in the bedroom except the bed, window, and night table. In your professional opinion, Officer Miller, do you believe the victim was forced into the bedroom?
It didn't appear so to me.
Thank you, Sheriff Miller. No further questions, Your Honor.
You now leave the stand. Our prosecution may continue.
Before calling forensic scientists to the stand, I would like to call in a few specialists to give the jury some background information on the processes used to analyze the evidence against the accused. These processes include DNA typing, genetic inheritance, VNTRs, and PCR. I'll begin with Dr. Kathleen Neiman.
Hello, my name is Dr. Katie Needham, and I'll be talking to you today about DNA typing. I'm letting you know what it is, how it's formed, and its importance. DNA typing is a process in which we extract DNA from a biological sample from an individual, such as skin cells, and analyze it. This creates the DNA profile for that particular person, which is always going to be unique unless this person has a twin. After extracting DNA, you have to go through a few other things before you can analyze it. This includes the PCR amplification of selected variable number tandem repeat markers. And then after that, you can then analyze it and match up with other DNA profiles. The purpose of the using DNA typing in this murder case is to match up the DNA found at the crime scene with the DNA of our suspects. This helps us by identifying unique molecular markers in each individual's DNA. If you look down here at the picture to your left, you can see that we have an example of two different suspects, a sample from the crime scene and the markers that we'll be looking for. You can then look at the number and the marker and match it up with the sample from the crime scene and the markers that we'll be looking for. If you look down here at the picture to your right, you can see the results of the DNA typing that we'll find. Thank you.
Thank you, Dr. Neiman.
You now leave the stand. Our prosecution may continue.
Next on my list is Doctors Fernandez and Zuniga.
Hello, this is Dr. Fernandez and I'm Dr. Zuniga, and today we are here to talk to you about fundamentals of genetics to help facilitate your further understanding of the situation.
So how are traits inherited? Traits are inherited by your parents and they are chosen by a genetic material called chromosomes. You have 23 different chromosome pairs which determine what you look like.
Let's start off with some basic terms. First term is a gene, and a gene is a unit of heredity that is transferred from one parent to offspring. So this right here would be a gene, these two red squares right here. And there's an allele. An allele is an alternative form of a gene, or one member of a pair, that is located in a specific position on a chromosome, and both parents give one allele to their offspring. So this allele will be given to you by like your mom, and this one will be given to you by your dad, and this will constitute you as homozygous for whatever gene this is. And then this one, since they're different colors, you would be heterozygous for whatever your mom gave you versus what your dad gave you.
So Punnett squares are diagrams that are used to predict an outcome of a particular cross or breeding. And in this example, it shows a Punnett square determining earlobe traits. The dominant trait is unattached earlobe, which is shown as capital B, and the recessive is the lowercase d. The results are the genotypes, and a genotype determines the phenotype. A person can be a carrier for both traits, like in the Punnett square in this example, but in the phenotype, only the dominant trait will be visible. So not all genotypes produce visible phenotypes in their children.
Could you please explain why genetics are relevant in cases such as this?
Oh yeah, sure. Well, using everything we know about genetics, heredity, and inheritance, we are able to say that no one person can have the exact same genetic makeup as somebody else unless they are identical twins. With this being said, we can use methods like a PCR process like VNTRs to find a particular person and pinpoint the perpetrator.
You now leave the stand. Who will the prosecuting counsel call next?
I'd like to call in VNTR specialist, Dr. Isaac Cunningham.
Hello, ladies and gentlemen. I'll be giving you a few facts about VNTRs. First things first, VNTR stands for variable number tandem repeats. These repeats are sequences of repeated nucleotides on a chromosome. An area on the chromosome is called a locus. VNTRs can be used to identify individuals by discerning their parentage. This is done by isolating and amplifying the desired region, or the locus, on the DNA. At each locus, an individual will inherit a certain number of nucleotide repeats from their mother on one allele and from their father on another allele. This allows us to kind of identify people as a kind of a DNA fingerprint. After amplification of the VNTR sequences through PCR, the sequences are ran through an agarose gel. This process, called electrophoresis, gives us the band sizes of the sequences and allows us to identify the person. Let me blow up this picture. Okay, so as you can see, let's just look at individual A. Individual A, if you look at all three different loci, you'll see that all three loci differ. And if you look at just this loci, you'll see that both alleles differ as well. Now, this doesn't always have to happen. You can be homologous, in which case both of the alleles will be the same size. But for the sake of this example, they're all different. And if you look at all three individuals, they are also different. In this example, we are trying to find which one of these individuals matches the forensic set. And down here, you'll see this is an example of electrophoresis. And each individual has their own different DNA profile in which we will try to match with the forensic sample. In this example, individual B matches the forensic sample. As you can see, you can line up the different strands, the different band sizes, and individual B matches perfectly.
Thank you, Dr. Cunningham. I would now like to call Dr. Vishal Sadakumar, a PCR specialist, to the stand.
Hello, my name is Dr. Kumar, and I'll be explaining PCR to you guys. What is it, how does it happen, and why do we use it? PCR stands for polymerase chain reaction. PCR is a fast and inexpensive technique to amplify or copy segments of our DNA for scientific analysis. So components in the PCR, what do we put in it? First, we start out with DNA, a genetic code that we're going to copy. Next, we have the primer, which will bind to a specific site on the DNA which we want to copy. And then we have the Taq polymerase, which is the enzyme that actually does the copying. And then we have nucleotides, which are the building blocks of our product. The primer can be manufactured to bind to any portion of the DNA. And in our case, we're going to bind to the VNTR of loci D1S80 to determine the size of the 10 repeats on the loci, which range from 14 repeats to 72 repeats. So how does the reaction work? First, we start off with our DNA. It's 2 strands. In the first step, the DNA is heated up to 94 to 96 degrees Celsius, and it splits apart. Next, the primer comes in and binds to the target location where we want to copy. After that, the Taq polymerase comes in and starts copying the DNA and elongating, as shown right here. This process is repeated over and over again, 20 to 30 times. So these 2 strands of DNA split again, and copy, and split and copy. By the 3rd cycle, we have our first specific products. Specific products are the portion of the DNA we want. By cycle 6, we have this many, and as you can see, it grows exponentially. By cycle 20, we have over 1 million copies of what we need. The end result. Once the reaction is complete, we can take an X-ray image of the gel electrophoresis and compare the images of the band lengths with the suspect's DNA and the DNA found at the crime scene. If we have a match, then we have the result. That's all. Thank you.
Thank you, Dr. Sadakumar. This concludes the background portion of our trial, and I would now like to hear from our consulting forensic scientists, Dr. Sierra Wright and Rachel Francis, concerning the DNA evidence found at the scene of the crime. Dr. Wright, what have you and your team recovered from the scene of the crime?
So in our forensics lab, we analyzed the samples taken from the crime scene, and using PCR, we amplified DNA to show the veritable number of tandem repeats, which you can see right here. The samples we found were blood from the broken glass, blood found on the victim, tissue from the broken glass, and tissue found on the victim. These results allowed for 3 separate individuals at the crime scene.
So there were 3 people present at the time of death?
Well, according to the police phone call made from Senator Martin, there were only 2 other people other than the victim, and so we ran samples from Governor Marc and Senator Martin, and these matched over here. So we ran this John Doe through a medical database and found that he was a blood transplant donor and also recently deceased.
Would the defense like to cross-examine the witnesses?
Yes, Your Honor. Dr. Francis, could you tell me the location of each identified sample?
The DNA of the unidentified person was found on the window, as well as Governor Marc's DNA. Senator Martin's DNA was found in the bed near the victim. This collected DNA was then analyzed through PCR. This process allows us to view various layers of DNA and to reveal which alleles are present within each suspect's DNA, how many of these alleles are repeated, and the frequency of said VNTR. By examining the bandwidth and the band placement, we were able to determine that Governor Marc's alleles repeated 24 and 15 times each, making him 1 in 1,124 people for these alleles. Senator Martin's alleles repeated 21 and 15 times, making her 1 in 6,859 people for this alleles. But however, the DNA analyzed for John Doe was homozygous for 29, meaning that both of his alleles were the same. And if you look on this image of PCR, you can see 2, 3, 4, 6, and 8. They are 2 individual bands. But when you look at numbers 1 and number 7, you can see that they're one thick band, which would be the homozygous allele. These results were very common, had a very common frequency of 1 in 343 people.
So basically, none of my client's blood was actually found in the bed of the victim, but the blood of the victim's wife was found in bed. And I want to remind you that the victim was strangled to death and was not bound before he was killed, so he must have tried to defend himself as he died. Further questions?
Thank you, doctors. I would like to point out that it does not matter that the governor's blood was not found on the bed, as he was not bleeding until he jumped out of the window. And I would also like to remind the jury of the bone marrow transplant Governor Marc received 1 year ago. It is most incriminating that this unique blood from the donor was found at the scene of the crime. It could only have come from Governor Marc, as my next witness, Dr. Bureau, will point out.
Good morning, my name is Dana Vera, and I'm going to talk about the bone marrow transplant. First, I would like to explain what is a bone marrow. The bone marrow is the spongy tissue that is inside our big bones, and it has cells that produce red blood cells, white blood cells, and platelets. So next, I would like to go to a transplant. The bone marrow transplant is a process to replace unhealthy bone marrow with healthy bone marrow. And since the suspect has leukemia, he got an allogeneic bone marrow transplant. This means that the healthy bone marrow was taken from another person, the donor, and in most cases the donors are siblings, but we can find another related donor that could be a good match too.
So a person who had a bone marrow transplant would have 2 potential sources of DNA, the original DNA and that of the donor?
Yes, a bone marrow transplant turns the patient into a chimera, and what I mean is that the DNA in his blood is different from the DNA in the other cells. As you can see in the given graph, the first one shows tissue examples in which you can see the donor's DNA and the recipient DNA. However, in the last one, which is only blood samples, you can only see the donor's DNA. This case shows that it is very important to test both blood and another tissue in a suspect body to make sure that they match the same DNA profile. Thank you.
Maybe see.
Thank you, Dr. Garrett. Before I call my next witness, I wish to explain why I do not believe the wife of Autumn Martin is a viable suspect. The fact that she is the victim's wife and that she lives in the same house as the victim supports this. I do not believe that it is incriminating that her DNA was found in her own home.
But my client recently gave blood. How do you know that the person who received this blood wasn't the perpetrator?
I'd like to call blood transfusion specialist Luke Rahman to the stand to explain why this does not change the DNA present in the individual's blood.
Good morning, my name is Dr. Rahman and I'll be discussing blood transfusion. To start off, blood transfusion is the transfer of blood from one individual to another. This is done to replace blood cells due to the lack of service. So in terms of organelles, if they're defective, they need replacements. So you would get new blood cells from individuals and in a way just transfer it so the others will work in the same way. So similarly, you would have no new DNA but the original from the same person. You do not get new DNA once you are transferring new blood. Thus, this concludes that when you have blood transfusion, you do not have new DNA.
Thank you, Mr. Rahman.
Would the defense like to counter?
Yes, Your Honor. How do we even know that the bands that show my client's DNA are accurate? The forensic scientists say the alleles are 24 and 15, but how are we sure they aren't 25 and 15?
I'd like to call specialist Dr. Fernando Tovar to the stand to explain why we have perfect reason to believe that these bands are accurate.
Hello everyone, my name is Fernando Tovar, and today I will be talking to you guys about how we analyze forensic DNA. The VNTRs were amplified and were run on the agarose gel. First off in this process, I wanted to create a linear regression model to compare the fragment size length to the fragment size migration to the gel, in which I had used the known DNA fragments as provided in the agarose gel. This is my linear regression model, and here's the equation that I came up with after I measured each band. We ran the DNA markers 3 times to get the best accuracy. These are the DNA markers over here. This is the example of linear regression. It displayed a higher regression value, meaning it was a great model. The closer it is to 1, the better, so I got 0.9877. I then went about measuring the distance of the DNA samples from the crime scene and came to the conclusion that the DNA samples from Governor Marc's DNA were 4 and 7, and they were identical, as you can see. His repeats came out to be 24 and 15. John Doe's DNA, which are 2 and 8, were the same repeat of 29 and were identical. And Senator Martin's DNA samples, which are 3, 5, and 9, were exactly identical to the blood samples that we analyzed, as well as having the repeats of 21 and 15. All in all, after I closely analyzed the size of Marc's DNA samples, we came to the conclusion that he was indeed present at the crime scene.
Thank you, Dr. Tovar. No further questions.
I'd like to call Doctors Michael Saavedra and Christopher Bandolima to the stand. Dr. Saavedra, how can we tell that this data presented by Mr. Tovar is accurate?
Well, before we should discuss any accuracy, we feel as though the jury should first know a little bit about population genetics, which my partner, Dr. Bacalino, will discuss now.
Hello everyone. So today we want to talk about population genetics. So what is population genetics? It's the study of alleles changes in the population and the causes of evolution. If you look at the picture on your right corner, you will see that there's some different organisms, but same organism but different traits, which are really unique. But in reality, if you look at it, they actually have same alleles. Why is that? So we're going to see on the next slide why is this. So here you will see 2 Punnett squares for different generation. On your left corner, you're going to see the first generation, and which was in this case we're talking about brown eyes and blue eyes, which brown eyes are dominant and blue eyes are recessive. So here on your parents on first generation, you're going to see that both parents have blue eyes, in which the frequencies are the same. No, frequencies are the same and the alleles are the same. On parent 2, second generation, you will see that both one parent will be blue eyes and the parent's brown eyes. If you look at here, you will see that all of them both here have the same alleles, but they have a different allele frequency, in which my partner, Dr. Sewanee, will talk about allele frequency.
Alright, so allele frequency is the relative frequency of an allele within a population. In population genetics, allele frequency is used to show how the genetic diversity of a species. Alleles, the allele frequency is usually demonstrated in either a percentage or a ratio of the total population that has a specific given gene. One example is eye color. As you can see down here, the gene for blue eyes is represented by this kind of orangish color. So if you look over here in like U.S. or rather North America in general, there's the gene for blue eye occurs very rarely, in fact almost not at all. Whereas in Europe over here it occurs, it's very, very common, occurring a lot of time. So allele frequencies correspond to the percentage of the population which has a given allele. For example, alleles with high frequency occur very often within a population, whereas alleles with low frequency are found very rarely within one. High frequency, or in cases like these, high frequency alleles allow for much more error in distinguishing individuals because two individuals have the same set of alleles. There's much more room for error.
So based on this data, my client has a very common allele frequency. So there is no reason your evidence can condemn my client when his allele frequencies are so common that anyone in the neighborhood would have been there. No further questions.
Does the prosecution wish to comment?
Indeed I do. The commonality of the suspect's allele frequency is of no consequence in this situation. The fact that he was undoubtedly there at the time of death and that his unique blood profile from his bone marrow transplant was found at the scene are enough evidence to condemn him and overpower this trivial fact.
Very well. Prosecution may continue for the next witness.
I now wish to question the suspect himself, Governor Brandley Marc.
Do you solemnly swear to tell the truth, the whole truth, and nothing but the truth? So help you God, murderer.
Governor Marc, you have yet to give an explanation as to why you were present at the time of death. Would you care to comment on that now?
I'll with you, Governor Marc.
We had an affair.
Order in court! Order in court! Governor Marc, you understand that you are under oath committing perjury is an indictable offense.
Yes, Your Honor. Elliot and I began our relationship during the campaign until we ended it to be with Autumn. On the 7th, however, I went over to congratulate Autumn, but she was not home. And then things with Elliot and I resumed to what they were before. But we were interrupted by Autumn, so I tried to quickly escape out the window.
Governor Marc, are you claiming that at the time you left, the victim was still alive?
Yes.
But samples of your DNA and various fluid samples were found on the victim. This evidence points to you committing the crime. How would you explain the attacks on Autumn?
I did not attack Senator Martin. I tried to leave as soon as I heard her come in.
Oh, is that why you tried to leave? Is it because you killed her husband?
Objection! Stay.
I have no further questions, Your Honor.
Your Honor, we'd like to call Dr. Sierra Wright to the stand again.
Dr. Wright, is it true that the skin samples were collected from under the victim's fingernails?
Yes.
Could you tell us whose skin cells these might be?
We found a match for Senator Mark.
Given that Autumn Martin walked in on my client and her husband, is that not motive to kill Elliot McClure?
Objection! Autumn Martin is not the one on trial here. All accusations made against her are irrelevant.
Stay.
We have no further questions.
Does the prosecutor have any questions?
No, Your Honor.
You may leave the stand.
Your Honor, I'd now like to call Senator Otto Martin to the stand.
Do you solemnly swear to tell the truth, the whole truth, and nothing but the truth, so help you God? Thank you.
Senator Martin, we have just heard from Governor Marc that when he fled from your home, Elliot was still alive. Did you kill your husband?
No.
Then how would you explain the story of your head injury and the scratches on your arms?
They were from garden.
So you had fresh scratches and bruises from gardening alone?
Yep.
At 10:32 at night?
Yeah, it's really hot during the day and like I sweat really badly and out of emotions.
Okay. Then how would you explain your skin under the victim's nails?
But while I was gardening, I realized that a few of my tools were pretty dry, so I went around the back to get those. On the way back, I tripped. And Elliot caught me in I guess his face.
So at 10:32, Elliot was in two places at once.
No, I think your timeline is off. I have no idea where Elliot went after he helped me. I went inside, cleaned up, and came back.
A man is dead. Your husband, Elliot McClure, is dead, and we have evidence that you were with him minutes before his death. Senator Martin, did you kill your husband?
Objection! She's badgering the witness. She's already answered that question.
Stay. Move on, Counselor.
No further questions, Your Honor.
You may leave, stand. Closing statements?
Ladies and gentlemen of the jury, I believe the genetic evidence collected at the crime scene is negligible compared to the overwhelming gaps in Senator Martin's story. She reported the crime. Her skin was found under the victim's nails. I believe Senator Martin found her husband and my client together, chased Mr. Marc away, and killed the victim, Elliot McClure. I have presented my case, and I believe that there is, in fact, reasonable doubt that my client committed this murder.
Ladies and gentlemen, I believe that I have presented the evidence against Governor Marc in the best way possible. It is my belief that Brantley Marc murdered Elliot McClure in a fit of jealous rage that escaped through the window. The victim's wife, Autumn Martin, had no motive for killing her husband, and so I say that the feeble evidence presented by the defense may be dismissed.
Ladies and gentlemen of the jury, that concludes the evidence given by both sides. If the defendant is found guilty of the charge, and he shall pay fitting punishment. If the jury finds the defendant not guilty, his case will be dismissed. You must make a decision based on the evidence given by the court today. Raise your hand if you think that Governor Marc is guilty.
Audience, you're the jury.
I do, I think you did.
The jury's verdict has read the Governor Brantley Marc to be declared guilty. He will be held in jail until the state arranges for him to be sent to prison and sentenced to death row.
Wait! I can't live with this anymore. I did it.